Welcome to my video on a review of the Scientific American from December 1975. I'm just going to go through and kind of look at some of the pages and talk a little bit about the articles. And there's a VW, I think that's a rabbit. I haven't seen those in a long time. This kind of goes through the list of articles there, and we'll just talk about a few of them. Mostly the physical science related stuff is what I kind of like. And so I'm not quite as much up on the biological stuff. Funny thing, I've got that Encyclopedia of Philosophy. I got that exact set. It's nice. Car advertisements up front. There's more advertisements. A lot of liquor and cars. Oh, here's kind of a Bell Systems. That's a big advertisement is what this is. Talking about the Bell system. And oh yeah, they always do this. They do 50 and 100 years ago and talk about what was happening 50 and 100 years ago. And right now, this is about 50 years later. So it's kind of funny. Probably the current one may have this edition in it. I don't know. I haven't seen it recently. Just more advertisement. Okay, yeah, that was right before the American Bicentennial, 1776, and we're in the 250th anniversary year right now, so it's kind of telling. Oh, there's a Monza. Kind of funny looking cars. My son-in-law's got one. An old one. Okay, here's the first main article. One thing about Scientific American has a lot of kind of complex articles, much more than your standard magazine. Strip mining of Western coal. Looks like it just talks about what's going on out in the western states. It shows where the coal is and how they're strip mining it and the economic and ecological impact of that. Okay, here's one on cell membranes. The energetics of cell membranes. So this is more biological nature, and it really, this is where this was starting to come into play. The Earth, life sciences are really important now because they're getting things really figured out, or starting to. And this article goes into some detail. Let's see, yeah. And this was kind of the first article that caught my attention. It's X-rays from supernova remnants. So those are stars that exploded, in these cases, many, many years ago, or decades or centuries ago. And when they do, they produce large quantities of X-rays by all the rushing ionized gas and spiraling in through the magnetic fields. When the electrons spiral along the lines of force of a star's magnetic field, they radiate by means of the synchrotron process, emitting radio waves, visible light, and X-rays. So they had sent up the orbiting astronomical observatory satellite Copernicus, and this had an X-ray telescopes on it, and they were starting to get X-ray images back. And this is the map of the supernova remnant Puppis, and you can see the white indicates the bright. So they're starting to look at these in not just optical, but in the infrared. And then there's another, this is the Cassiopeia A, another supernova remnant. And then this is a radio map, so that's the radio frequency, and then this is in the X-ray frequency. And I assume they're at a fairly close scale. Let's see, missing the page there. Okay, yeah, this is the Crab Nebula M1. I've got a video on that, a picture I took of it, and visible. It's on somewhere on my the Math and Physics Learning channel. Welcome to take a look at it. And they're talking about here, they would take these X-ray images as the moon passed in front of it, and so they could kind of block out different sections of it and try to get a little finer resolution view. And this just goes through the stages of a supernova remnant explosion. So this is pretty much an astronomy article, kind of interesting. And okay, Science and the Citizen. This is just kind of an update on different things going on. In this case, it's the Nobel Prizes. I just kind of scanned through this. Nothing really jumped out at me too much except this one right here for A.G. Bohr of Niels Bohr Institute of Copenhagen, and this Ben Molson and Nordic Institute of this in Copenhagen, again, rediscovered. Okay, this A.G. Bohr, that's the son of Niels Bohr, who won the Nobel Prize in 1922, I think it was. That had to do with the Bohr atom. He was one of the founders of quantum mechanics. And so that was his son. He had, I think, 6 sons and 2 died, but they all, well, not all of them, but many of them became very noted scientists or academics of some sort. And so this talks about just different little articles, short articles. Oh, this one was kind of fun, I thought. That's the portable computer from IBM from about 1975. And I remember something vaguely similar to this. I don't remember that particular one, but they were pretty big. And this one programmed in APL, which I've never really messed with. BASIC was the standard language. That's the first language I learned. And it's got a maximum of up to 64K characters. So by today's standard, that's microscopic. We take pictures that are 10 times that big now with our iPhones. So that's kind of interesting. That's what the portable computer would look like 1975. I thought that was kind of neat. Oh, here's another article, The Arrow of Time. And this is pretty much a physics article. It talks about irreversible process, irreversibility, and processes move in one direction as a general rule. It's got to do with the second law of thermodynamics. This law states that all natural processes generate entropy, a measure of disorder. The irreversible destruction of a macroscopic order defines what I shall therefore call the thermodynamic arrow of time. They give the example of a bottle of perfume. As it evaporates over time, it just fills the room, and really you just can't get the perfume back in the bottle. So the arrow goes in one way. It's an irreversible process. And here they're mapping out like the individual atoms, what they would do, and that can be reversed. Well, we can measure it, but it's kind of a little paradox as to why in the whole you can't undo it, but on one item you can. So it's here they're talking about phase space, which takes into account the velocity and momentum and the directions, a little more detailed information about where the particle is at. Oh, and also I've got a little note here. I do have a video on thermodynamics on my math and physics learning channel, and another diagram here of the probability of things fill the cavern there. So it talks a little bit about entropy. The concept of entropy is closely related to the concept of information. Entropy was first defined by Rudolf Clausius and Lord Kelvin in connection with thermodynamics, and it measures the displacement of a system from thermodynamic equilibrium. So that's an important concept, and it's also rather confusing in some places. In thermodynamics, it's kind of probably less understood. This is talking about the phase space. The dynamical state of a single particle is completely described by the position and its velocity. To express those quantities, we need 6 numbers, 3 coordinates of the position and 3 components of the velocity. When you combine all that, you get a phase space that gives you an idea of what's happening, not just in space, but also in the relation to the velocity and energy. So that talks about just kind of some basic understanding of, I guess, more cosmological implications of the arrow of time. That's kind of a bit philosophical and practical too. This one is what happens to the human lens and cataract, and I kind of looked over that a little bit because I'm the age to where that's a happening thing. So just see what happens to your eye as you age and you get a cataract. Oh, here's a cool ad about a Polaroid. I used to have one of these. I don't know if it was that particular model, but that was so neat when those came out. You could just punch a button and a picture popped out after a few seconds after it self-processed. That was a slick invention at the time. It's more about the cataract and the lens. Pretty detailed on that. I should probably read that more carefully. Let's see. Okay. This one. This was 1975, so this is 1973 and 74 were the main years of the oil crisis. The price of oil shot up. I think everybody realized that we needed oil. And you can talk about whale oil because that was kind of the end of the period. They were actually using whale oil for a while, well, centuries, and this was kind of the end of that, and they're getting more into the technology of oil. And this one I didn't fully read all. I kind of glanced over. This is just rather strange by Western standards. Among the Common people of Africa, the bridegroom promises a sister to the family of the bride for marriage. The practice is an organic part of economic, social, and moral systems. By Western standards, that seems a little unusual, definitely, but whatever. The world's not set by Western standards. So this just talks about how that works out, and then all the linkages and all the chromosomal breakdown of how all the genes get matched. I bet it's a mess. A lot of relationships there that's quite complicated. Okay, this gets down to more the microstructure of polymeric materials, polymers, and then how they are put together, a little bit of their microchemistry of what's going on there in the polymers. Let's get this page open. You can tell these pages are kind of old. They're getting kind of tattered around the edges, kind of hard to open up. So this is the microcrystalline structure, and it's kind of microscopic view and how they might be all intertwined together, the complex molecules. And let's see what we've got. Oh, this is Pure Life Sciences, the sand wasps of Australia. Talks about these big wasps. Those look pretty scary, and where they live and all that, kind of their life cycle and how they mate and propagate, and you see it kind of goes into some details. And this is another Quasar. They were big into telescopes. I'm not sure what happened to them. Anybody knows, put me a comment, I'd like to know. Oh, this one was the one that really tickled me. This was just basically when the little handheld calculators were coming out. You can see $24 for one of these. Now they're almost free, $2 or $3 each. Little story about that. This was during the time I was in high school, and I had a part-time job, and I saved up my money, and I live in a rural area, and got a calculator. It was a Nixie display calculator. Paid $63 for it. I was working for $4 an hour, so I put a lot of time in to get that calculator. It was kind of the big ooh and ah of the school, and this one girl stole it out of my locker and was parading it around the school, and the principal caught her and got it back from her. I think he kicked her out for a day or two, gave it back to me. So it was quite a deal. It caused a real commotion among the kids because nobody had seen one of those yet. And I was kind of a nerd boy, and I had to have one. Mathematical games, I usually have a section on this, and I'm not super big into those, but they're kind of interesting. I was looking over this section of its sequential model. Okay, a sequential model of the anti-twist mechanism. I was kind of going through that in my brain and not sure I fully follow all that. Probably need to read that in detail, but they always have a section on this. It's kind of amateur scientists. It's kind of neat stuff you can build or think about. This is the one that kind of caught my eye. Basically, if you've got a propeller up here and the propeller in the water, what happens is the wind blows. If you direct the propellers in a different direction, it's going to push back. So as the wind blows toward it, it's actually going to go into the wind if you've got these ratios properly done here and all the drag and everything. But that's kind of neat. It goes into the wind because this big propeller here drives this little propeller down here that pushes in the opposite direction. So the stronger the wind blows, the faster it goes into it, I guess. Thought that was kind of cool. And let's see, books. Oh, it goes into different books. I kind of looked through that to see if I have any of those books. I saw some familiar names. I didn't see any of the books that I have, the authors. I did see Isaac Asimov in here somewhere as one of the authors. He was big during that period. He wrote, I think he wrote 500 books, most of them are technological related. I've had several of them over the years. I think he had a bunch of graduate students working for him. I don't know how you could write 500 books. I've only got like 80. That took a lot of time. So this just goes through the books issued right in that period, in case you want a book. And then it just kind of wraps up with some of the people, some more advertisements. And of course, another liquor commercial. They love liquor commercials. I guess that pays the bills. That makes sense. There's another one. All right, well, I hope you enjoyed this little tour of down memory lane of the December 1975 Scientific American. I enjoy doing these. I like looking at them and seeing all the stuff in there, what's going on. If you do, give me some comments. Let me know what you think about this stuff. And I'll thank you for watching.